Hi there, I'm Shantanu from Ipinfusion. I'm an architect here. So today I'll be talking about segment routing. Segment routing is a brand new technology which is come to the networking space, and it is changing the way we do the routing. So traditionally IP routing, as we know, it just looks at the destination IP address and makes all its forwarding decision based on that. But in segment routing, the routing is based on segments. So there is a list of segments which are injected into the packet, and the routing decisions are based on the segments which are injected into the packet. And the segments indicate the exact path which the packet has to follow in the network. So there are two major reasons why segment routing is gaining so much of popularity in the current market. One major reason for that is segment routing promises to achieve all that the current MPLS protocols were doing by simple extensions to our current IGP protocols like OSPF or ISIS. So we need not run an extra protocol like LDP or RSVP to achieve traffic engineering or other MPLS use cases. The next major reason for segment routing's popularity is the SDN use case. So segment routing can help us deploy SDN. As we know, in SDN, all the processing is getting centralized. And in a centralized server, we are able to find what is the topology of the network, as well as what is the traffic statistics, all the other information related to that. So how segment routing helps is using this information, where it can form the exact path which the packet has to follow to reach its destination. And this can be programmed by segment routing. So what is segment routing? In segment routing, the entire network is modeled in terms of segments. So the major elements of this network are like the node, the prefixes, and the adjacencies. So for each of them, entity is determined by a segment. So for example, the node segment is the one which represents the node itself. The prefix segment is the shortest path to the prefix, and the adjacency segment is like the IGP adjacency to its neighbor. So what happens in segment routing is when the packet enters into the segment routing domain, it will be look for the destination address, and based on that, one or multiple segments will be injected into the packet. So the forwarding decision will be based on this segment. So if there is a single, for example, if there is a single prefix segment introduced or a single node segment introduced, it will just follow the normal IGP shortest path to the prefix. But if we have multiple segments introduced into the packet, it will follow the exact path which the segment is indicating, basically the node or the prefix or the adjacency, before reaching its final destination. So how it's achieved? The nodes, the prefixes or the adjacencies are given with some identifiers, which we call as segment identifiers. These are 32-bit identifiers. So these identifiers are distributed by the IGP, the existing IGP protocols like OSPF or ISIS. And based on the flooding scope, these are distributed to the other nodes. For example, the prefixes are generally distributed to the entire domain, routing domain. The adjacencies, SIDs may not be required to be distributed everywhere, so it will be local to the node. The interesting aspect of segment routing is the forwarding of the segment routing can be achieved by the existing MPLS hardware. So how is it achieved? A segment is a 32-bit, but it can be modeled into an MPLS label which is as a 20-bit. So it can be converted into an MPLS label of 20-bit. So our existing hardware which is supporting MPLS forwarding can achieve segment-based forwarding also. So, and also as I mentioned, all the use cases of MPLS can be achieved by segment routing, and there is no need to add extra protocols like LDP or RSVP, and the existing IGP protocols can achieve what the MPLS protocols were currently achieving by these extensions. Yeah. So let's see how segment routing works. This is a very basic scenario in which we will achieve just default routing using shortest path. And the packet needs to be routed to the node 106. So to achieve this, we assign a node segment 106 to the node, and that information is distributed to all the other nodes. So when the packet comes to the ingress node, what the ingress node does is it injects a label corresponding to the prefix segment 106 into the packet. This is an MPLS label which is pushed onto the top of the packet. Now when the packet reaches to the next node, it will just do a swap operation on this. So we have like this, and in the penultimate hop it will just pop this label, and it will reach, the packet will reach to the destination node of 106. So this is the case of a very simple IGP shortest path which we are achieving using segment routing. So let's see the second scenario. This is for a traffic engineering explicit routing case. So here we'll see how a packet will be forced to go via 104, 105 and then to 106 instead of going directly from 104 to 106 like the shortest path which we see in the previous example. So every node is assigned node segments, like you can see from 101 to 106. When the packet arrives at 101, that is the ingress node, it will push a list of segments into the packet, 104, 105 and 106. So the packet reaches to 102 via IGP. In 102, since the top of the label stack is at 104, so it does a penultimate hop for that, and the packet is given to the node 104. In 104 again, now it looks up that the top of the label stack is 105. So it gives it towards the node 105 with the penultimate hop pop. So we get now only the label 106 remains, and now the node 105 gives the packet to 106 with the penultimate hop pop again. So let us see how segment routing with PCE can now help us achieve SDN in our network. So the topology information and the other statistics, etc., can be collected by the BGP LS or extensions to the existing IGP protocols. So all this information is now available in a centralized place, right? And now by using PSEP protocol, we can program in the ingress node what is the explicit path which needs to be taken for a particular service. So since segment routing has helped us to model the entire network in the terms of segments, this information can be easily programmed externally from an external controller, and the rules can be injected into the ingress nodes. This is how we can achieve SDN using segment routing. So what are the segment routing use cases? The two major use cases which the segment routing is serving. One of them is it provides an alternative to LDP. So LDP, as we know, is an MPLS protocol, and it provides label mappings for all the prefixes which are present in the routing domain. So with segment routing, we don't require to run an extra protocol for this label mappings. These label mappings can be achieved by the existing IGP protocols which are already running in the network, like OSPF and ISIs. So this is a very important use case in which the load of the network can be reduced, and it can be made much more simple than its current state. So Ipinfusion is adding support for this use case currently, and it will be available shortly in its ZebOS XP product offering. The other use case and major one which the segment routing is an alternative way to achieve traffic engineering. So traditionally traffic engineering was achieved with MPLS RSVP protocol. However, the path has to be formed and each node had to maintain states for that. But in segment routing, it's a very effective and flexible way of doing traffic engineering, in which on integration with PC, we can encode the entire path in a list of segments, and we can add it into the packet, and just we need to look at the packet to know what the path has to be followed. Since it is integrated with a PC and a centralized controller, it's much more flexible and easier to implement than the traditional MPLS traffic engineer. However, I would like to highlight that currently there are few challenges in this. The challenges like The current hardwares, which MPLS supported hardware, has only 3 label stack support, but this limits the number of segments which can be pushed to 3 segments only. So this is the current limitation, but once it is overcome, I think it will be serving a very nice use case. So this is just a snapshot of what we have implemented in ZebOS. So this is just showing, as you can see in the highlighted area, that the OSPF has been extended and it is distributing prefix segments for the prefix 1.1.1.1 with an SID value of 1024001. So this information is propagated all over in the OSPF network, and that's how the segment information is available and flooded to the network. So as I mentioned, this offering will be available in the current release. So let's summarize the benefits that segment routing is offering. First of all, the traffic engineering and the VPN use cases it is able to achieve by existing IGP protocols. And one major thing is currently there is no changes required in hardware to support this segment-based forwarding. It is just a change in the control plane. And the much more important part of it is it's very simple to implement, and it has much less states maintained in per node. I mean, in a current MPLS deployment, we have to maintain states for what the path has to be followed. But here the states are available within the packets itself about how it should be forwarded. As I already highlighted, the one major use case is integration with SDN and the centralized control and decision making about how the packet will be forwarded, and that can be programmed directly to the ingress node. So for example, if an application is requesting a very time specific SLA for forwarding, so the OpenFlow controller integrated with the PCE can program the path in the ingress node, and it can be achieved. Another use case is, another benefit of it is application enabled routings. For example, an application can request to the OpenFlow controller for a time specific SLA, and this can be directly programmed into the network. So it's very flexible and it can be achieved in a very simpler manner than in the current way, which requires directly going to the configuring the node and the ingress node and all that. So another major benefit is it can achieve ECMP shortest paths and traffic can be load balanced in the ECMP paths. Also the IP MPLS FRR can be fast reroutes can be achieved by this segment routing. So segment routing is here to make networking more simpler and more flexible than before, and is a promising technology for the next generation of networking, where we can control network traffic from a centralized controller in a much more efficient manner. Thank you for watching this video.